The universe seems to be endless with no signs of life. While a lot of us might believe there is no extraterrestrial life out there, no one can prove otherwise. But recently, scientists made an incredibly shocking discovery when looking at the second planet from the Sun, Venus. They claim to have found life. But how is it possible that we haven't detected life before on Venus until now? And is there really life on Venus? Venus is an incredibly hot world, but research seems to suggest it once had vast oceans. It's possible that Venus could have been as habitable as the Earth, but in the last billion years, greenhouse gases transformed the planet from an oasis to the uninhabitable hell it is now. The scorched surface becoming too harsh for life forms, they may have retreated deep into the ground or into the atmosphere to avoid extinction. In order for us to look at the possibilities for life on the planet, it's interesting to know a little bit about Venus and its evolutionary history. Chances are you've seen the planet Venus many times and didn't know it. You can easily see it from Earth because it's the brightest object in the sky next to the Sun and Earth's moon, and it's visible as a bright star in the morning and evening sky. It's one of only 4 terrestrial planets in our solar system and considered the Earth's sister planet. Venus is about 20% smaller than Earth and is smaller inside with an iron core 2,400 miles wide. We can't see the surface of the planet from Earth because Venus is covered with thick clouds. But there have been space missions that show it's covered with mountains, volcanoes, craters, and huge lava plains. And for the record, those spacecraft didn't last long. This is because temperatures on Venus are hot enough to melt lead at around 880 degrees Fahrenheit, hot enough the ground would glow a dull red. The atmospheric pressure at the surface is 92 times the sea level pressure on Earth, or the same as being 3,000 feet underwater. It would crush you, and any spacecraft not built to withstand the immense pressure. The thick clouds are mainly carbon dioxide, but also have a layer of reflective sulfuric acid with the smell of rotten eggs. It's not a place you would want to be, or could survive more than a few seconds. Venus is too close to the Sun to sustain life as we know it, and averages a distance of about 67 million miles away from the Sun. However, about 3 billion years ago, the Sun was only 80% as luminous as it is now. With that in mind, it's possible that this hellish planet could have had an environment much like the Earth, and for about 2 to 3 billion years after the planet formed, life could have had plenty of time to emerge. The Pioneer Venus spacecraft launched by NASA in 1978 and several other space explorations have helped us study the planet and reveal some details on how it transformed from an Earth-like planet to the hellish place it is today. Evidence was found showing there may have been shallow oceans on the surface of Venus for 2 to 3 billion years, and temperatures on the planet would have ranged from a low of 68 degrees Fahrenheit to a high of 122 degrees Fahrenheit. It would have been easy for life to flourish under these conditions, and where there is water, there is a good chance of life. Ancient Venus was certainly a lot different than it is now, and it's been theorized that it formed out of ingredients similar to Earth, but followed a different evolutionary path. Its rotation rate around the Sun is 117 days compared to Earth's 1 day. But scientists say it's possible Venus once had the same rotational period as Earth. It had more dry land than the Earth, especially in the tropics, and the surface was ideal for making the planet habitable with plenty of water to support an abundance of life, and there was plenty of land to reduce the planet's sensitivity from incoming sunlight. But around 700 million years ago, some kind of massive resurfacing event triggered a runaway greenhouse effect, causing the planet's atmosphere to become very dense and very hot. No one knows for sure what caused this massive catastrophe to happen, but some researchers believe that volcanic activity may have been the cause, as magma and molten rock bubbled to the planet's surface, releasing huge amounts of carbon dioxide trapped in the planet's crust when it rapidly cooled after forming 4.2 billion years ago. This sounds like a scary occurrence, and similar events have happened here on Earth. The Siberian Traps is a huge 3 million square mile region of volcanic rock in Siberia, Russia. It's the evidence of a massive eruptive event that happened in the last 500 million years. The 2 million year eruption released toxic amounts of greenhouse gases and caused a mass extinction. So now that we know quite a bit about Venus, could simple life forms be struggling to survive on the planet after millions of years? And how would we know? Recently, scientists say they've discovered a chemical called phosphine in the clouds of Venus. Phosphine is made up of 1 atom of phosphorus and 3 atoms of hydrogen. It's also been detected here on Earth, on Jupiter and Saturn. So, how is this discovery of phosphine evidence for life? The one thing that got researchers excited about the smelly flammable gas is that, as far as we know, phosphine can only be made by life, whether it be humans or microbes. Humans have made it to use as a poisonous chemical weapon that was used in World War I, and it's still made as an agricultural fumigant. But the interesting thing is that phosphine is also made naturally by some species of anaerobic bacteria. These are organisms that survive in oxygen-starved environments, such as landfills and marshlands. With that in mind, researchers set out looking for phosphine on other planets, since finding it could indicate the presence of alien metabolisms, and they found it in the clouds of Venus. Using the largest astronomical telescope in the world, the James Clerk Maxwell Telescope and the Atacama Large Millimeter Array Telescope, researchers measured trace gases in the Venus atmosphere. Phosphine should not be in the Venusian atmosphere at all. It's extremely hard to produce, and the chemicals in the clouds should destroy the molecules before it can accumulate in amounts large enough to be observed. So, what could be creating the phosphine? Some scientists say it's too early to conclude life does exist on Venus, and that the data needs to be verified, and the phosphine fingerprint could be a false signal introduced by the telescopes or data processing. But if phosphine is really floating through the clouds on Venus, it suggests one of two things. Alien life forms are linking together phosphorus and hydrogen atoms, or there is some completely new chemistry that we don't know about that's creating phosphine in the absence of life. Despite the sulfuric acid in the clouds of Venus, they also carry the basic ingredients for life as we know it: sunlight, water, and organic molecules. And scientists have speculated for nearly 60 years that life could possibly exist on the planet. Near the middle of the cloud layer, temperatures and pressures are nearly Earth-like, and there are molecules in the planet's air that alien microbes could metabolize. The possibility of finding bacterial life in the clouds of Venus is important, because the earliest evidence of life on Earth comes from fossilized mats of cyanobacteria called stromatolites in Greenland, which are around 3.7 billion years old. But the fact that life could live in such extreme environments is something we already know about. Around 4 billion years ago, there lived a microbe called the last universal common ancestor, or LUCA. There is evidence that this microbe lived an alien lifestyle, because it was hidden deep in underground iron-sulfur-rich hydrothermal vents. Being both anaerobic and autotropic, it didn't breathe air, and made its own food from the dark, metal-rich environment it thrived in. This microbe's metabolism depended on hydrogen, carbon dioxide, and nitrogen, which it turned into organic compounds such as ammonia. The most remarkable thing of all was this tiny life form was the beginning of a long lineage that covers all life on Earth. Now that the biosignature of phosphine gas has been discovered in the clouds of Venus, there are missions being planned by several institutions, including California's Rocket Lab, who plan to send a spacecraft to Venus in 2023 to hunt for definitive signs of life. The mission will use 2 pieces of Rocket Lab hardware: the 57-foot-tall Electron booster, which is currently used to launch small satellites into space, and the Photon satellite bus, which recently made its debut flight. The Photon will launch atop the Electron booster, then it'll make its way to Venus on a flyby trajectory. When the Photon gets close enough, it'll deploy a probe into the atmosphere. Its goal will be to hunt for signs of life in the deck of Venus air that is habitable. But before the mission, everyone will get a chance to see the Electron and Photon in action, as it's booked to take a NASA satellite to the Moon in early 2021. And speaking of NASA going to Venus, they have 4 finalists for the next round of Discovery missions. 2 of these newly announced finalists are targeting Venus. One of these is the Da Vinci Plus mission, which would send a probe down through the thick Venusian atmosphere while gathering data on the way. The second is the Veritas mission, which is set to map Venus's surface in detail from orbit. This probe's observations would help show the planet's geological history and could confirm if volcanism and plate tectonics are active on the planet today. It seems there's no other place in the universe with a dense atmosphere. Mountains, sand dunes, plains, lakes, rivers and oceans, except the planet Earth. But it turns out there's actually a place much like the Earth in our solar system that has a complex weather cycle, landscapes carved by liquid, and volcanic activity. It may even resemble the Earth in its earliest stages, and some scientists think it might be better to colonize it first instead of Mars. This is Saturn's moon, Titan. Recently, something bizarre was found hidden in its orange clouds, and because of this, NASA is now planning a mission to Titan. But what did they find, and why was it so important? Before we get to that, let's learn a little about this strange world that orbits Saturn. Our solar system is home to more than 150 moons, but only 4 of those have an atmosphere. One of those is Titan, the second largest moon in our solar system and the largest moon of the planet Saturn. Titan is also the only place in the solar system other than the planet Earth that has liquids on its surface. It has a weather cycle much like ours, but has clouds that rain frozen liquid methane and ethane instead of water. Titan could be the best place for human colonization. In fact, the conditions are right for a self-sustaining, long-term human settlement. Titan is a remarkably Earth-like world that has a thick atmosphere, about 4 times as thick as Earth's. The atmospheric pressure is about 60% greater than on Earth. Imagine swimming 50 feet underwater to give you an idea. This means you wouldn't have to wear a bulky pressurization suit if you were walking around on the surface. The atmosphere would also keep out deadly radiation, energetic particles from the sun, and galactic cosmic rays from making it to the surface of Titan, making it a safe environment for humans. Mars doesn't have such protection. People living on Titan could walk or bounce around since gravity is only 14% of the Earth's. If you strapped some wings on yourself, you could literally fly around under your own power. But it's very cold on Titan, because on average it's 886 million miles from the sun. You would need a suit to keep warm, because the surface temperature is about minus 290 degrees Fahrenheit, and the only sunlight that reaches its surface is like late sunsets on Earth. Of course, you'd also need to wear a respirator to breathe. Titan is tidally locked to Saturn, meaning one side always faces the planet. It's 759,000 miles away from Saturn and has a radius of about 1,600 miles. It takes the Titan 15 days and 22 hours to make a full orbit of Saturn and 29 Earth years to make a complete orbit around the Sun. No one is certain what Titan looks like under the surface, but on January 14, 2005, the European Space Agency's robotic lander Huygens made a dramatic descent through the moon's orange smoggy atmosphere and landed on the surface of the moon. The camera on Huygens shows a desolate-looking surface and captured the trademark yellow haze, which revealed intricate details of the atmosphere's layers, winds, and mysterious chemical processes. Based on data from the Cassini-Huygens mission, Titan has 5 primary layers of rock. The soggy moon has a core of water-bearing silicate rock surrounded by a shell of special water ice called Ice 6 that's found only at extremely high pressures. This high-pressure ice is surrounded by a layer of salty liquid, and an outer crust of water ice sits on top of this. The surface is coated with organic molecules that have rained or settled out of the atmosphere in forms of sands and liquids. The presence of lakes and seas on Titan brings up an interesting question. Could there possibly be any forms of life there? In 2005, scientists at the Southwestern Research Institute in Texas and Washington State University said that several of the crucial elements for life on Earth are also on Titan, even though the conditions are far harsher than Earth. Some life forms are a lot tougher and stranger than we think. Take, for instance, Deinococcus radiodurans bacteria, an extremophile that was in outer space for 3 years outside of the International Space Station, enduring microgravity, harsh ultraviolet radiation, temperatures near absolute zero, and still managed to survive. If there's life on Titan, it could be hidden underground, and a lot weirder than we think. The Cassini spacecraft revealed that the moon is hiding an underground ocean of liquid water mixed with salts and ammonia. Titan could potentially have environments with conditions suitable for life as we know it in the subsurface ocean, or bizarre alien life that we don't know about yet in the hydrocarbon liquid on the surface. But what happened there recently that drew our attention there? In 2016, a team of scientists identified a molecule called cyclopropenylidene, C3H2, in Titan's atmosphere that's never been detected anywhere else except deep space. The discovery was made using the Atacama Large Millimeter Array, ALMA, that's made up of 66 radio antennas. These all work together, creating a single giant telescope. ALMA uses a technique known as interferometry, where all antennas are pointed in the same point in the sky. The antennas pick up a signal from the target in the universe and join forces to analyze the signal. By combining radio waves from the antennas using a supercomputer, researchers can obtain extremely high precision images. In order for ALMA to get these images, there must be a perfect synchronization between all 66 antennas and the electronics with the precision of a millionth of a second. Using this incredible technology, researchers found something they didn't expect to find: a weird molecule called cyclopropenylidene. C3H2 is a strange organic molecule that doesn't exist terrestrially on Earth and can only be seen in a laboratory. C3H2 was first discovered in clouds of gas and dust throughout the Milky Way, including the Taurus molecular cloud. This simple carbon-based molecule may be a precursor to more complex compounds, and it could form or even feed possible life on Titan, like organic molecules that formed life on Earth between 3.5 and 3.9 billion years ago. C3H2 is the only other cyclic or closed-loop molecule besides benzene to have been found in Titan's atmosphere so far. Closed-loop molecules like it are important because they form the backbone rings for the nuclear bases of DNA and RNA, which is also a critical compound for life's functions. However, C3H2 is not known to be used in any modern-day biological reactions. NASA says the molecule could be an indicator for life, since something has to be generating an unstable molecule. If there is life on Titan, it would be incredibly different from water-based life forms we know of. NASA was so intrigued by this new discovery on Titan that it wants to study the moon more and announced the Dragonfly mission in 2019, which is planned to launch in 2027. It'll take 9 years for it to reach Titan, arriving in 2036, and will cost a total of $1 billion, including its ride into space. The Dragonfly is a very unique spacecraft design and is much like a large quadcopter drone with 2 rotors on each of the spacecraft's 4 corners, hence the name Dragonfly. When it arrives at Titan in the year 2035, it'll need to travel to different areas for study. The Mars Curiosity rover used special tracks to roam the red planet, but with Dragonfly, scientists decided to take advantage of the moon's low gravity with a flying vehicle. This will be the first time that NASA will fly a multi-rotor spacecraft for science, and Dragonfly will be able to make vertical takeoffs and landings. Despite the lower gravity on Titan, it still needs electricity to fly around. So the Dragonfly is equipped with a radioisotope thermoelectric generator, a type of nuclear battery that converts heat from decaying plutonium-238 into electricity. This means it could fly and operate on Titan for decades. Since Dragonfly can easily fly around, it can be moved so that it's always facing the Earth for direct communication, which takes 70 to 90 minutes each way, since Titan is so far away from the Earth. During its proposed 2.7-year mission, Dragonfly will take advantage of the dense atmosphere that'll keep cosmic rays and radiation from destroying it. And it will fly to many different locations to pick up surface materials for chemistry experiments. It'll also check out the planet to see if it's possible for humans to inhabit it one day. Since the building blocks of life, or the organic molecules on Titan, are expected to be similar to those on Earth before life arose, Dragonfly will help study how far pre-life chemistry has progressed to see how life evolved on our own planet. See, we have no idea how life really formed and began on our planet. All we know is that it involved organic molecules. Dragonfly will check out the moon's atmosphere, what the surface is made of, and the ocean that lays below the surface, looking for complex organic materials that are the keys to life. Now, the only thing left is to build the spacecraft and get it ready to launch. Even if we don't find what we're expecting there, the Dragonfly mission will show us a lot more about Titan. It seems that we may soon find life on another planet or moon, and that'll be a very exciting time for science and humanity. Jupiter's biggest moons were discovered 400 years ago by Galileo. Io, Europa, Ganymede, and Callisto are each fascinating worlds. Some could hide oceans that could hold life. Now, NASA claims that the Juno spacecraft has detected an FM radio signal coming from one of these giant moons. Where did this signal come from? How did NASA find it? And what other secrets are Jupiter's other moons hiding? We saw your comments about wanting to hear more about the strange FM signal coming from one of Jupiter's moons, and now we've delivered just for you. Enjoy! Something recently happened that caught everyone's attention. NASA's Juno spacecraft is still out there wandering space, and for the first time since it was launched, it picked up an FM radio signal coming from Jupiter's moon, Ganymede. This is the same kind of signal that you would find here on Earth. In fact, we use this signal every day and know it as Wi-Fi. Did we just pick up an alien radio station broadcast from Ganymede? To figure that out, we need to know more about this icy alien world. Ganymede is the largest moon in the entire solar system. If it was orbiting the Sun, it would be a planet itself, being larger than Mercury. Although Ganymede doesn't have an atmosphere, it's the only known moon to have a powerful magnetosphere, which sometimes produce auroras that are affected by the moon's underground saltwater oceans. The rocking seen by the auroras gives researchers evidence that the underground oceans on Ganymede are possibly liquid and very salty, far saltier than the Earth's oceans. The FM signal that came from Ganymede originated from electrons in electromagnetic fields, a process causing the electrons to whirl and oscillate much slower than their spin rate. The Juno spacecraft detected the 5-second radio burst in late 2020, when the moon crossed a polar region of Jupiter where the gas giant's magnetic field interacts with Ganymede. So could there be life on Ganymede? Well, we know for sure the signal didn't originate from alien life. It's also very cold on Ganymede, with temperatures around minus 186 degrees Fahrenheit. However, during one of its flybys, the Galileo spacecraft detected a dense stream of atomic hydrogen escaping from the moon's very thin atmosphere. This means that there are large amounts of oxygen that's locked up or hovering over its icy surface. Atomic hydrogen is the lightest atom, and Ganymede has a weak gravitational field, so the hydrogen escapes and the atomic oxygen stays behind. Some researchers say that Ganymede could have as much oxygen on its icy surface as the Earth has in its atmosphere. So could Ganymede have everything for life to exist in its subsurface oceans? Some scientists think the pressure at the base of any ocean here would be so high that it would turn to ice. But a mission is needed to find out more. But this moon isn't the best candidate for life. In fact, there is another moon orbiting Jupiter that some scientists are calling the most habitable place inside our solar system. Europa is an icy white moon with brownish streaks on its surface and has an icy crust that could be from 2 to 20 miles thick. It's the smoothest surface of any other object in our solar system, and you wouldn't find any mountains or craters here. Underneath the icy surface would be a vast underground saltwater ocean, which could be twice the volume of those on Earth. Europa is very cold, with an average temperature of minus 260 degrees Fahrenheit, which keeps the icy crust as hard as granite. But could life still exist here? It's possible. At the dawn of the space age, it was thought that all life depended on the sun, and any object too far from a star would be a frozen ball of ice unable to support life. But finding thriving ecosystems at the bottom of Earth's oceans relying on hydrothermal vents changed all that. Now we know life is pretty tough and it can survive completely isolated from the energy of a host star like our Sun. It's important to know this because Europa could harbor simple microbial life in liquid oceans underneath its icy crust, and this life could be surviving off the same kind of hydrothermal vents. So how do we know that Europa probably has liquid water needed for life to thrive? The Galileo spacecraft that flew over the moon in the 90s uncovered evidence of a vast, deep, dark, global subsurface ocean. Even though the moon should be a solid ball of ice, the water on Europa doesn't freeze completely because it's constantly churned by powerful tidal forces as the moon orbits around Jupiter, and at the same time, those tidal forces cause Europa's core to generate heat. Scientists are excited because this global ocean is thought to be in direct contact with surface ice and the moon's silicate mantle. This brings together everything needed for a habitable environment: liquid water, a source of energy, and a source of minerals and nutrients that life needs to flourish and survive. We know some bacteria or extremophiles like tardigrades can survive extreme environments, and just maybe, Europa's hidden ocean could have these kinds of life forms. Between 2014 and 2016, researchers got evidence that there might be liquid water on Europa. Hubble Space Telescopic images showed evidence of huge geysers of water vapor, some 62 miles high, erupting from the surface over Europa's south pole. Although some researchers aren't sure, we're going to find out soon enough. NASA wants to send a probe to Europa by 2025. The spacecraft is called the Europa Clipper, and it will explore whether this icy moon has conditions suitable for life or not. The $2 billion solar-powered probe will fly by Europa 40 to 45 times using a number of high-tech instruments to study the moon's icy shell and the ocean that's underneath the surface. Will it find life? Only time will tell. And what about the Jupiter moon Callisto? Is it possible life could exist there as well? Callisto is the second largest Jupiter moon and the third largest moon in the solar system. It's almost the exact same size as Mercury, but with a surface temperature of negative 218 degrees Fahrenheit. It was once thought to be a dead moon because of its ancient cratered surface. In fact, it has more craters on its surface than any other object in our solar system. If you have many craters on the surface of any astronomical object, it means that geological processes are probably dead. But Callisto also orbits too far away from Jupiter to be affected by the gas giant's magnetosphere and heavy gravity. However, Callisto may also have an underground ocean, and the satellite's icy crust might be acting like a cosmic blanket, insulating this underground ocean. It's not clear whether this ocean could hold life because the surface is so old. The only way to find out for sure what's happening on these icy moons is to send a probe. NASA and the European Space Agency are building the Jupiter Icy Moons Explorer, or JUICE, which is planned to launch sometime in 2022 and begin a 7.6-year cruise to Jupiter, arriving sometime in 2029. We've all heard about the James Webb Space Telescope and the amazing potential it will have to find habitable exoplanets. But the JUICE probe is going to be carrying the most powerful scientific payload ever flown to the outer solar system, which includes 10 state-of-the-art instruments, plus will perform an experiment using the spacecraft telecommunication system with ground-based instruments. During the first part of its 3.5-year mission, the JUICE probe will make 30 observation overflights of the 3 icy moons Callisto, Europa, and Ganymede, studying them in close detail by examining their gravity, magnetic interactions, and checking to see if liquid water really does exist under the surface of each one. It'll then investigate whether these oceans might hold the organic components necessary for life, or even life itself. There's another interesting moon that's been grabbing the attention of researchers lately, but it's not in Jupiter's orbit. However, we think it's worth mentioning if we're going to talk about finding life in the solar system. In 2019, NASA revealed the ocean on the Saturn moon Enceladus contains the building blocks for life. This vast water ocean is about 6 miles deep and lies under an icy crust that's 19 to 25 miles thick. Images of huge plumes of water vapor erupting through cracks at the south pole of Enceladus were captured by the Cassini spacecraft and indicate there must be an underground ocean. These plumes were analyzed by the folks at NASA and found to contain water vapor, ice, salts, methane, along with simple and complex organic molecules, the kind of stuff normally found in living systems. The newest study of Enceladus shows the moon is more geochemically complex than previously thought, and that carbon dioxide is being controlled by chemical reactions on the seafloor of an interior ocean, boosting the chances of the Moon having some kind of life. On Earth, oxygen-breathing creatures consume energy in organic matter like glucose and oxygen to create carbon dioxide and water, and oxygen-breathing microbes can metabolize hydrogen to create methane. NASA's Cassini's Ion and neutral mass spectrometer detected methane, carbon dioxide, ammonia, molecular nitrogen, and molecular hydrogen in the plumes. And molecular hydrogen would indicate there is free energy available in the oceans of Enceladus. Cracks in the ice where the plumes erupt have temperatures warm enough that seems to show the ocean is being heated by the Moon's core. These hydrothermal vents could be similar as the ones found on the Earth's oceans and are hotspots for life. A team of scientists now want to send a probe to the Moon to find out. It's called Orbilander, which would cost $2.5 billion. The probe would orbit Enceladus for 200 days, which won't be easy considering Saturn's giant gravity field. Orbilander will fly through these plumes of vapor, which will then funnel into science instruments at high speeds. But this probe won't only orbit the Moon, it'll also land on the surface, and so it will need to find the perfect place. Once the location is found, the probe will convert to a lander. 2 nuclear power sources will keep Orbilander running on the surface of the Moon for up to a year and a half while it sends data on what it finds back to Earth. If humanity wants to explore the universe, we'll have to learn how to colonize and terraform other worlds. But what exactly would it take to terraform a planet? And do we have the technology to make a planet like Mars comfortable for us? Discover what stands in our way of terraforming, which places in our solar system are the best for human colonies to be built, and find out how we just created oxygen for the first time on another planet. Planet Earth is the only place where humans can exist, for now. It's a scary thought that if our planet suddenly started to become uninhabitable, we'd have no place to go. Mars is one planet in our solar system that could be colonized. NASA wants to put humans there sometime in the 2030s. But when we send humans to Mars, they'll need a way to return to Earth safely, and those astronauts will also need oxygen to breathe. Mars is a cold and desolate world with a thin atmosphere that's made up of 96% carbon dioxide. NASA already has several rovers running around on the Martian surface checking it out, looking for signs of ancient life and seeing how habitable the planet might be. The Perseverance rover recently landed there, and it brought with it a very important experiment called MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. It's a small toaster-sized box that has 3 main components. On April 20th, 2021, MOXIE became the first instrument to create oxygen on another planet by separating oxygen atoms from carbon dioxide molecules while using high levels of heat for the conversion. During the first run of MOXIE, it produced about 5 grams of oxygen. That's about 10 minutes worth of breathable oxygen for an astronaut. But this small car battery-sized unit can only generate 10 grams an hour. But now that MOXIE has proven it can produce oxygen, NASA plans to build a much larger unit, about 100 times larger. Another big achievement of MOXIE is that it's the first kind of technology that just used elements of another world's environment and turned it into a usable resource. NASA calls it in situ resource utilization. Oxygen is also needed for rockets, and to get off Mars, a ship or rocket would need about 33 to 55 tons of fuel. That's where liquid oxygen comes in. Mars-made liquid oxygen could supply more than 3/4 of the fuel needed to explore the red planet, and could also fuel other missions to nearby planets and moons. And if you mix hydrogen and oxygen together, you either produce water or hydrogen peroxide. And water is another important resource that we're going to need. 3 billion years ago, an ocean covered 1/3 of the Martian surface, but now 99% of Mars water is ice. It should be possible to melt this ice and filter it so that it can be used. When it comes to colonizing the planet Mars, we could build big domes and pressurize those with a breathable atmosphere using a MOXIE system. But building domes and living inside them is no easy task, and we need to be sure we're up for that challenge. Take, for instance, the Biosphere Project, which was a compound built in Arizona to see if we humans are able to build and live in self-sustaining colonies in outer space. We have a more in-depth video on the Biosphere Project you can check out. Thanks to this project, we now probably understand exactly what we need to build these domes out of, and how we might be able to survive inside of them. Technology has come a long way since then, and Elon Musk says that we would live in big domes made of glass at first, and then we'd eventually terraform the planet over time. Colonizing Mars definitely seems possible, but is it really possible to terraform the planet? For those who don't know, terraforming is the process of taking a barren or desolate planet like Mars and turning it into an Earth-like or somewhat habitable environment. It sounds good in science fiction stories, but Mars has big problems that our current technology cannot overcome, not as of yet. Mars has a very low atmospheric pressure, currently less than 1% of the Earth. That pressure would have to be increased a lot to sustain an atmosphere. Elon Musk joked about an idea to nuke the polar ice caps on Mars, and minerals and soil could also provide a source of CO2. But even if we used nuclear weapons and processed all those sources, we would only increase atmospheric pressure to about 7% of the Earth, which is 1,013.25 millibars, or about 14.7 pounds per square inch. That means that any liquid water on the surface of Mars would freeze or evaporate quickly. And using nuclear weapons might only put the planet into a nuclear winter. It's still possible that there is enough carbon-bearing materials buried deep in the Martian crust that might hold enough CO2 to reach the pressure needed, but no one knows this for certain yet. But it's not the only problem. Mars is missing a magnetosphere, which means it will be difficult to maintain an atmosphere and ozone layer protecting the planet from solar radiation. And because the planet lacks any plate tectonics, it makes it incredibly difficult to introduce and isolate the proper amount of greenhouse gases life needs to survive. Mars also has lower gravity. Now, you might think it wouldn't be a problem, but lower gravity poses high health risks like bone demineralization, muscle atrophy, and weaker immune systems, as seen in some of our astronauts at the International Space Station. Mars is a cold and desolate place. But why fly to another planet if we want to try terraforming a cold and frozen wasteland? It seems the USSR wanted to do something similar, where palm trees could grow in Siberia, and the cold sea shores would turn into sunny, sandy beaches full of tourists. In the 1960s, there was a proposed plan by a Russian engineer named Petr Borisov, who wanted to build a dam across the Bering Strait. The reason is that 80 million years ago, at the boundary between the Mesozoic and Cenozoic, the Earth was in one of its most favorable states. The latitudes of Siberia and Alaska were in the subtropical zone, and the Arctic islands and Antarctica were covered with forest. All that's needed to return the area to this state is to restore the Cenozoic water exchange between the polar basin and the equatorial seas. But building a dam like this would take an incredible amount of resources. The width of the strait in the narrowest part is 45 miles, and the maximum depth is 193 feet. It was proposed to build the dam from large reinforced concrete blocks delivered by the sea. The width of the pontoon blocks would have to be 131 feet by 820 feet long, with a height of 65 to 196 feet. The dam itself would have been 55 miles long. The result would have been an increased flow of heat to the Arctic, and gradually the Arctic Ocean would lose all its ice, and temperatures in the northern part of Eurasia will increase. Of course, this project never took place, and we can already see the warming of Siberia now. But what about something not on Earth, but right next door? It turns out that the Moon has long been considered a potential site for terraforming. One of the reasons it would be easier is because it's a lot closer to us than Mars, and transporting people and equipment would take a lot less time. Because it's close, any resources or products made on the Moon could be shuttled to Earth in much less time. And a tourist industry would definitely pop up, with people wanting to go to the Moon for their vacation. But the Moon has a really thin atmosphere, if any at all. and the volatile elements needed for life don't exist there or are in short supply. In an impossible task of creating an atmosphere, you'd need to bombard the surface of the moon with comets that contain water ice that would release gases and water vapor. The presence of water ice in the lunar soil and large patches around the southern polar region could be used to create surface water once a greenhouse effect was triggered. Getting the moon to start to rotate again by crashing asteroids into it, since it's tidally locked to Earth, would also have to be achieved. All this sounds really impossible, but there's another idea to terraform a place on the moon called Shackleton Crater, where scientists have already found evidence of water ice. By using solar mirrors and building a dome over the 13-mile-long and 2.6-mile-deep crater, a microclimate could be created where plants could be grown and a breathable atmosphere created. Once again, we lack the technology to pull any of this off, but it still might be possible to see some type of subsurface installation built on the moon for future human explorers. Another surprising place that we might be able to terraform one day is Venus. Venus is considered Earth's twin because they're almost the same size in mass and are rocky terrestrial planets. Venus also orbits the Sun in the habitable zone, and it's close, making it easier to transport explorers and supplies. The gravity of Venus is about 90% of what we experience here on Earth. Venus doesn't have a problem with a thin atmosphere. In fact, it's the opposite, and is 90 times thicker than the Earth's. The surface of the planet is also hot enough to melt lead, and the air is a toxic combination of carbon dioxide and sulfuric acid. It definitely doesn't sound like a place you want to visit anytime soon. But despite this being a hellish world, scientists think it's a better candidate for terraforming than Mars. Reducing the heat in the atmosphere would be the first thing on the list, but this would require a huge amount of energy and resources. Using advanced materials which likely don't exist yet, a huge orbital shade large enough to cool the atmosphere enough could be built. However, we're talking about a structure that would need to be 4 times as big as Venus itself, and it would have to be assembled in space, which would require a massive fleet of robot assemblers. Increasing the speed of Venus's rotation would also have to be done, and this would require a huge amount of energy, such as directing several asteroids into the planet using large fleets of spaceships equipped with advanced drive systems. But thousands of impactors would be needed. But there is even another world out there that scientists say could be terraformed. The Saturn moon Titan is appealing as a place to terraform because of its vast reservoir of resources. Its hydrocarbon reserves, such as petroleum, are several hundred times greater than all known reserves on Earth. It's covered in a wide variety of organic compounds, mostly methane and ammonia, and it has a lot of water. Its atmosphere is primarily nitrogen, resembling that of early Earth. Together, all this stuff has the main ingredients for a perfect place to terraform when we have the technology. To change the atmosphere, one idea is to position huge mirrors in orbit to direct sunlight onto the moon's icy surface, which is ice and contains many greenhouse gases. This could warm the place up considerably and at the same time release water vapor, which would in turn oxygenate the atmosphere. Titan also orbits most of the time with Saturn's magnetosphere, which would protect it from the solar wind. Despite all the major technological challenges we face, most of humanity believes that we need to find a second home in our solar system. The big question is, which one should it be, and when will it happen? Let us know what you think, and make sure to stay tuned here for more amazing videos of our planet and the universe we live in. Thanks for watching.